you guys have down there. And when you get a chance, we just like to see which teacher brings in the most students. So somewhere on that side, just vote for whoever your teacher is. Vote for your teacher. Sometimes we just like to have a little competition, friendly competition. So yeah, so vote for the teacher that you have, and type in any questions you have, any topics you want us to go over, any practice problems you want us to do, talking about sig figs, conversions. I could test your skills. Like lab questions, all that. So first few minutes, I always just leave it open for you guys, just so that you have time to figure out what you want to go over. So remember, this is all going to be based on what you guys want. Can you please go over with dogs? Like, you want me to use dogs as examples? Sig fig stuff. That's all I got from yours. So we'll go over sig fig rules. We'll do some sig fig math. Yeah, so we'll do sig fig stuff. That's definitely a big one. Other big topics were like dimensional analysis. There's knowing parts of the periodic table, but that's really just you guys going through the notes and looking at your periodic table. No other questions? All right. We'll just start with sig figs and then we will get started. All right. So basic sig fig rules. We'll go over it. Basic sig fig rules. There are 4. Rule 1. Non-zero numbers count. Always. Meaning if you're looking at a number or some sort of data point, non-zeros numbers will always count. Meaning any number 1 through 9, they'll count. So example would be something like 1987. That would have 4 sig figs. Because the 1, the 9, the 8, and the 7, they're all non-zero sig figs, so they all count. So typically, kids or students don't have problem with that. I was confused with 0.0 has 2 sig figs or 1 sig fig. It actually has. We'll talk about it. So that's typically the easiest rule that we'll talk about. Anytime you see a non-zero, that's when your sig figs will count. Then the next 3 rules are all about the zeros. So that's where students have the most trouble when it comes to just figuring out if the zeros count. So sig fig rules for zeros. 07E is just 0. I don't know. First rule with zeros is that zeros sandwich. So I like to call these sandwiched zeros. That just means it's going to be zeros that are between non-zero numbers. That just means things like 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 7. all those zeros in the middle count because all these zeros are sandwiched by this 1 and the 7. So this one would have 3, 6, 9, 12. This would have 12 significant figures. So sandwich zeros, anytime if you look to the left of a zero, if you keep looking, all you have is zeros, and then you have a number, and you also look all the way to the right, and there's a number, that means that will have, those zeros will count. Sandwich zeros, they will count. Second zero rule is zeros, I guess I'll switch it up. I'll say zeros in the beginning, the beginning of a number, never count. Ooh, that comes to an interesting question that Crucial brought up. So things like, just because depending on your teacher might want you to write, if you do like 0.02, some teachers don't require you to write this zero, so then it could be like 0.02. So based on whether or not your teacher likes it or not, that's where you can get a little bit confusing. So zeros in front of a number, they never count. So something like 0.0.000000008. This, all these zeros don't count, but this 8 will count right there. And notice that it doesn't matter if it's before or after the decimal. It's just saying, hey, if the first numbers you're writing are zeros, all those zeros will never count. 0.01, 0.1, all those zeros never count. So these zeros, the sandwich zeros, will count because there's a number in front and after the zeros. Zeros in front of a number will never count. And the last one for zeros, saying zeros at the end of a number count if you see the decimal. So now we're talking about zeros at the end. So if you think about it, so 100 versus 100 point versus 100.000, and then versus 0.0101. Let's do that. 2, 3, 0, 0. All right. Let's see what you guys think. Since there's only, what, 7 of us, anyone feel like drawing? I could give you access and you guys could draw, and then you guys could try to write in your answers in each of these to tell me how many sig figs each of these have. Anyone want to give it a shot? All right. Anyone else? Sure, but I need paper. I'll try. All right. And a fourth person? We have Alec, Kushal, Noah. We'll have Alec go here. We'll have Kushal go here. We'll have Noah go here. Anyone else? All right, then I'll do that. Okay, Aiden will go here. All right, let me give you some drawing privileges. Enable drawing for Aiden, enable drawing for Alec, enable drawing for Kushal. So now you guys can draw. You can pick whatever color you want. Noah. So all four of you can start drawing now. And just type in or write in how many sig figs you think they each have. How do you draw? I don't know. Aiden's got it. There's like a little tab on the left side of the whiteboard. If you open it, they'll have like colors and all that. Yeah, on the left, click the marker thing. Yeah. It's like this. It's the one right below the arrow. So Alex got it. Aiden's got it. It might be different if you're on the phone. Possibly. It's like Noah and Kusha, you guys are on your phone. Or I guess you could just type it in. There's no real reason for you guys to draw. It's just kind of fun to draw. All right, I'll put in your answer, Noah. 3. Kushal, what do you think? 6. All right, let's talk about it. So this one, Alec wrote 1, and that's good because, hey, we have a 1 here, so this definitely counts as a sig fig. And then if you look at these two zeros are at the end. So all right, okay. So at the end of my number, will the zeros count? Zeros at end of number count if there's a decimal, and if we look at this number, hey, we don't see a decimal. So that means these zeros do not count. That's why sig fig is 1. Good job. If we look down at Noah's, same exact number, but the only thing we added was a decimal at the end right here. That means we know the 1 for sure counts. And hey, these zeros are at the end. So that means, hey, they do count if we see a decimal, and we see a decimal, so it does count. So they work out. So 3. Good. And now this one. A lot of students ask, like, Mr. Lee, what happens if there's zeros in front of the decimal and after the decimal? So remember, we don't care about where the zeros are in relation to the decimal. We only care about if there's a decimal and where the zeros are, if they're in the beginning or the end of our entire number. So if we look at Kushal's number, it's like, hey, look, we have a 1, it for sure counts, and all of these zeros are at the end of my number, meaning, hey, the zeros are the last things that I'm writing, and the zeros at the end only count if there's a decimal. Hey, look, there's a decimal here, so 1, 2, 3, 4, 5, 6 sig fig. So that's also good. And the last one that Aiden did, it's combining all of the rules. So the very first rule is non-zero digits count as sig figs. So we have this 1, 2, and the 3. So we at least have 3 sig figs. Then the second rule we went over was that the zeros that are sandwiched in between other numbers, they do count. So that means this 0 right here is a sandwiched 0, so it counts. The third rule, or the second 0 rule we talked about, was the zeros in front of the number, they never count. So if you look here, these zeros are at the very beginning of my number. It doesn't matter that there's 1 before the decimal and after the decimal, but if you're writing the number, the very first numbers that you're writing are 0. You're doing 0.0. It's like, oh, and zeros at the beginning of the number will never count. Then you check the last zeros down here, which, hey, these zeros are at the end, and they only count if there's a decimal. Even though it's very far away from the decimal, right here, you still see a decimal, so they do still count. So then you get 1, 2, 3, 4, 5, and 6. Would you look at that? You guys all got it. So that's sig fig rules, where it just goes into just looking at a number and figuring out how many sig figs it is. But remember, that's not the main point about sig figs. It's figuring out, all right, the least precise measurement after we add stuff, after we multiply things. So once we get through all that, let's practice some. So we'll do one more practice. I'll give you a bunch of random numbers. Yeah. So those of you that just came in, typically if you never have come to a GBL, as you type in your questions, if you look right next to the chat box, I set up a place where as you write your questions, I'll type in the topics that you want to cover. So we're going over sig figs. We'll do a couple density stuff, and we'll do some unit conversion things. So any other questions you guys could think of, I'll type it in. But yeah. So last few just random sig fig numbers where it's like. mm, mm. All right, we'll call this like A, B, C, D, G. All right, try to figure out the correct number of sig figs for each of these. Ready, set, go. And if you want, you guys could type it into the chat box, and as other people answer it, you guys could check each other, be like, oh, hey, I think it's like this because blah, blah, blah. We'll give you like 1 or 2 more minutes, and then we'll go over it. And if you guys want, you guys could just do what Dylan did, just list them in order, so you don't have to type in like A, B, C, D, things like that. Save time. Ooh, all right, let's talk about it. I feel like a couple of these names are familiar now. Kaylin, did you go to Bio GBLs last year? I'll just some of them because I feel like I remember seeing your name on a couple. I'm trying to access the computer version. It says like something is blocked. You might need to download a plugin, but also Chrome is not the best. Like for me, I use Chrome for everything except this. I use Firefox for GBLs. For some reason, it works better. Yeah. And then you might need to like allow a plugin or something. All right, for the first one is good. The 1 and the 1 do count, and the zeros count because they are sandwiched zeros in between those two ones, so that is 4. The 2, the 1, the 3, and this 1, they do count, meaning that this 0 counts because it's sandwiched. And this 0 only counts because we see that decimal right there. So 1, 2, 3, 6. Then C, the 8 and the 7 count, meaning the 0 counts because it's sandwiched. These zeros unfortunately do not count because there's no decimal at the end. Or the zeros at the end don't count because we don't see a decimal. So this one is 3. This one, we're starting to combine a couple of the 0 rules. Zeros in front of a number never count, even if there's a decimal. The 1 and the 2 count. And this 0 does count because it's at the end and we see a decimal over there. So this is 3. This one, the 2, the 3, and the 7 count. That means that this 0 counts. And all these zeros at the end of our number, they do count because we see that decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This 1 counts, and none of these zeros count because there's no decimal at the end, so that one's just 1. And the last one, these 3 zeros don't count because they're in the beginning. This 1 does count, and these 3 zeros at the end do count because of that decimal right there. So that's going to be 4. So 4, 6, 3, 3, 10, 1, and 4. So close. All right, let's talk about the math stuff. So anytime you're multiplying, I guess I'll do a marker. So 23 minutes, we talked up until just sig fig rules, or I guess what is a sig fig? And from 23 minutes to whatever, we'll be talking about sig fig in math. So when we are multiplying, dividing, typically what I say is, hey, do the math normally. Check sig figs from the numbers you used. And then 3, round answer to lowest sig fig. That just means like if we do 3 times 5, this is my favorite one. So step 1 is just do the math. If you do 3 times 5, that's 15. Then we have to check our sig figs. That just means, hey, this number 3 had 1 sig fig. This 5 had 1 sig fig. That means my actual answer needs, or this one, they're both the same, 1 sig fig. So that means I have to round. So remember, this is in my tens place, this is in my ones place. I want to keep my first, or I guess my biggest sig fig. So that's going to be the tens place. So I want to keep this one like that. But I have to check to see if I have to round. And I do have to round because it's a 5. That means that 1 is going to become a 2. But remember, where is this 2? What place? It's currently in the tens place. So you can't just leave it at 2 because this 2 is in the tens place. So that means you have to include the blank 1 space as a 0. So then that would be your answer as 20. So 3 times 5 in this case is 20. So multiplying, dividing hopefully isn't that bad. You're really just doing the math and just going back to the very beginning. Okay, this had this many sig figs, this had this many sig figs, and then you just round. Whereas adding and subtracting, a little bit different. Do the math, check sig figs. This one I still don't really know the best way to word it. Basically like which numbers sig fig ends in the biggest place. That's where you're going to round to. So that just means like if you add 100 plus 11, yeah, there will be some element stuff. So we'll talk about, at least for my class, we'll talk about everything that will be upcoming on the test so that you know how to study and prepare for it. So 100 plus 11 to normal people is how much? Hey, Ryan. Nice, 111. But then, so we check sig figs. So there's a couple ways to explain this. You can say which number sig figs ends in the biggest place, which number runs out of sig figs first. So in this case, for the 100, these zeros don't count, remember? So the sig fig ends in the hundreds place. There's the tens and the ones place. So it ends in the hundreds place, whereas the 11, it ends in the ones place. So if you have the option of ending in the hundreds place or the ones place, you want to go with the biggest place. Or some people just like, all right, which one is farthest to the left? Which one runs out first? So then your answer would actually just be 100. Because if you have 111 and you need to keep it in the hundreds place, so you want to keep this, you just have to check to see if you have to round that 1 up to a 2 or keep it a 1. But that's going to become 100. Other people, what they like to do when they do the math portion, if you actually do the adding and subtracting vertically, it helps if you know where the sig figs end. So if you did like 100 plus 11 vertically, it's 111. But if you draw like squiggly lines to show where the sig figs are, it'll show you, hey, this sig fig ends right there. This sig fig ends right here. And the one that ends first is the one that we're going to follow. And then so you can follow this line all the way down. That means we keep everything on this side. So we definitely keep the 1 in the hundreds place. Then the rest just becomes zeros. Of that. So we'll give you some problems. You use scientific notation whenever you want, really. There's no right or wrong time to use it. And I don't know these answers yet, so we'll figure it out. Big numbers. All right, try these out. I'll be back. It's hot in here. I need to get a fan. Nice. Look at you guys doing some math by yourself. All right. Let's do it in green, I guess. 203 times 17.002. Doing math just like a normal person. You would get 3451.406. But like some of you guys did, you guys have to check for sig figs where, all right, this one has 3. This one has 1, 2, 3, 4, 5. 5 sig figs. And since we're only multiplying, we want to go with the smaller sig fig, 3. So I keep my first 3. So my answer is at least going to be 3, 4, 5. And then remember, that 5 is still in the tens place. So you have to drop down to get that 0. So 3, 4, 5, 0. Right. Good. 0.1 divided by 7. Try to give you some not fun numbers. 0.014285 dot dot dot. And we're dividing, so this one has 3 sig figs. This one has 1 sig fig. So your answer is actually just 0.01. 3 plus 7. Ooh, this one is tricky. Because if you think about it, it's just normally 10. But where do my sig... So we're adding now, so we have to see where my sig figs end. Both of my sig figs end in what place? Yeah, you always have to show your work. So at least setting up the math. So 3 plus 7 is normally 10, but 3 and 7, both their sig figs end in the ones place. That means my answer also has to end in the ones place. So my answer is actually 10 with a decimal. So that one threw a lot of you guys off. Because remember, so we did the vertical line, if that helps. 3 plus 7, right? It's normally just 10. But my sig figs end in the ones place. That means I need to make the rest of these significant. So that means I have to include that decimal there. Yeah. Yeah, we could do something like if we did like 10 plus 3, this one normal people would be 13. But if you look at this top 10 right here, where does the sig fig end for this 10? What place? In the tens place, whereas the 3 ends in the ones place. So that means my answer, so if you had the option of either ending in the tens place or in the ones place, you want to go with the one that ends first, which would be the tens place, if you're reading kind of like left to right. So then my answer, if I draw like a dashed line all the way down, I want to keep that tens place. So my answer would actually be 10 without a decimal. So a little confusing. 23 times 82. This one becomes 4.938 times 10 to the 25th. Based on this 82, we only want 2 sig figs, so this becomes 4.9 times 10 to the 25th. Remember, with scientific notation, we don't care about this part for sig figs. Then 4183.2 times 13. So that gives us 54381.6 over 127.8 divided by 127.8 gives us 425.5211 ... And then based on the 13, which has 2 sig figs, the 127.8 has 4 sig figs, 4183.2 has 5 sig figs, so my answer is going to be 2 sig figs. So my answer is 420. Is that what you all wrote? 430. Oh, you're right. It is 430. 430. This is going to sound very unscientific, but if you have a line that slices nothing, you need a dot. If you have a line that slices nothing, slice nothing. Oh, like with the 3 plus the 7 one. I don't get why students can't help the chemist because you're omitting a large portion of the actual answer. So good. Like, so why are we getting rid of all of these numbers? Like, if we have all these exact numbers, why are we getting rid of all these numbers? So the whole point of significant figures is to provide the most precise data. Meaning, okay, what's good visual? Let's see if this works. So let's say you're trying to add up these two bars. And let's say this is bar A, bar B. And you want to see if you put these two bars together, how long it'll be. And let's say person A, they have a ruler. But it only shows, let's say, 0 and 10. No other graduations. I don't know if this is going to work, but we'll see what happens. Whereas the other person has a ruler. It does go from 0 to 10, but they have, let's say, all the way to the millimeter. So let's say, they kind of look the same, but let's say the block A, block B, they're different sizes. Person B, they could say, oh, I know that it's at least, let's say these are centimeters. I know that this is at least 9.82 centimeters. Like that. Whereas this person, they only have that 0 to that 10. So they're like, it's kind of past the 5, 6. I'm going to say this is like, they have to estimate it's less than 10, more than 5. I'm going to say it's roughly 8 centimeters. Because remember, they can't estimate all the way down to the point something something. So if you were to add these two numbers up, you would think you have 17.82. But remember, the person A, their measurement tool was very imprecise. It didn't give them a lot of answers. So you actually don't know if this 0.82 is true. All you really know for sure is that, all right, I know it's less than 10. So all I'm for sure about, or what I know for sure, is the ones place. It's going to be less than 10, so it's somewhere in that less than 10. So that's why you can only keep those first two and know, like, you could tell someone 100%, say, hey, it's at least 17 centimeters. We don't know if it's like the 0.82 part. So that's why we use significant figures. And it's kind of like a chain link, or like a chain link like that. Similar idea where the chain is only as strong as the weakest link. As soon as this link breaks, the entire chain breaks. Similar idea, like a bunch of people could have this ruler, but since one person has this ruler, you can't become that specific. So yeah, so you could think of like imprecise data points as the weakest link, and you have to, in a sense, like slow yourself down to that slowest person or that weakest link. That sounds strange, but can you do a problem like x plus z showing sig figs? Yeah, so adding, subtracting, all that stuff. So if we do 3 plus 502 divided by 17. So this is where you get to know your PEMDAS. Please excuse my Jared and Sally order of operations. So if you do it on top, it becomes 505 plus 17. So currently I'm doing math, pretending like I know nothing about sig figs. 505 divided by 17, we would get, how would you, how would you do like that? Well, this it could be on the test, because you should be able to do all types of math with sig figs. But let's do this smaller example first, and then you should be able to do that stuff. So looking at Aiden's problem real quick, 2 sig figs, 2, 3, 2, 2, 3, 3, 3, 2. So Aiden's answer would only have 2 sig figs, because all you really did was multiply and divide, and that's pretty simple. You just count the one with the lowest number of sig figs. This one that I'm doing might be a little bit more difficult, because now you're combining adding, subtracting with multiplying, dividing. So remember, step one is just to always just do the math like a normal person. So here's doing the math like a normal person. Yep, always do sig figs last, because that's when you're rounding. So even anytime you do any of the homework problems, chem problems, all that, always just do all the math, like on the test, do all the math when assuming you know nothing about sig figs. Then that's when you go back and check what your sig figs are. Does anyone have a guess as to what our actual answer is? Let's see some answers. Let's see what you guys think. And then we'll see what the actual answer is. Remember, it doesn't matter if you're wrong or right, as long as you try. So Aiden thinks it's 30 with a decimal point. Alec also thinks that. All right, let's talk about it. So typically this is how I go about figuring out the answer based on my sig figs. I work backwards. So once I do all the math, I found out, okay, if I just do the math normally, it's 29.70588 dot dot dot. Then I think back, okay, in order to get this number right here, I came directly from this number right here. So I look here, I'm like, okay, hey, this is division. I know division. This has two sig figs. This looks like it has 3, this number right here. But where did I just get this number? I got this number from this addition part right here. So to figure out the sig fig of the 505, I had to figure out the sig fig based on this. So now the 3 plus the 503, this one ends in the ones place. This one ends in the ones place. That means my answer for the addition part has to end in the ones place. So now we know, okay, this 505 actually has 3 sig figs. So now between 3 sig figs, 2 sig figs, my answer needs 2 sig figs. So the answer is actually 30. Yeah, we'll do things with water. Because we needed 2 sig figs based on this right here. 2 sig figs. So if we do another one, this one, I'll try to think of it so that I could get more variety of answers. That's true. What can I do so that they're not nice, easy numbers? All right, try this one. I don't even know the answer. So I'll at least tell you the answer. If a normal person did this, it would be, oops, 0.952116 dot dot dot. Let's see how your sig fig skills have prepared you for this problem. And after this problem, we'll do some density problems, we'll get to unit conversions, then we'll talk about water and how water is so special. Kushal's final answer of 0.95212. If my Chromebook calculations are correct. Dylan says it's 0.95. Alex says it's 0.95. Aiden says it's 0.95. Oh, Aiden changed his answer to 0.952. What's it gonna be? Anyone else have an answer that they think? Annabelle says 0.95212, which is the same as Kushal's, I think. Yeah. So we have three different answers. I'm always curious. When other people are typing, can all of you see who's typing as well? Or is it just on my end I can see? Oh, you guys can also see. Wait, some of these answers are confusing me. Aiden changed his answer to just one. Oh man. Salty Merlin says one. There's one sig fig. All right. Should we go over it to see? All right. So this is where you get to remember the order of operations. Oh, a bunch of people are changing the answer to one. Let's see. Let's see. So if we do the top parts, the 7.32 times 4.183, 1. So we get 35.23116. Then we do the bottom part, you get 37.003, like that. Then you divide the answers, you get 0.952116. Now we have to figure out, all right, the last thing I'm doing is dividing, right? I'm dividing the top by the bottom. But let's first look at let's go with the top. Top one will be easier. Let's look at my top number, my numerator sig figs. What two numbers did I multiply together to get 35.23116? I multiplied 7.32 and 4.813. So I use this one, the 7.32, which has 3 sig figs, and the 4.813 has 4 sig figs. So that means my numerator technically should have how many sig figs? Just my numerator, the 35.23. Yeah. So without rounding, I'm just writing myself a mental note that my numerator technically has 3 sig figs based on my numerator math. So my denominator, though, I was adding and subtracting. So if I just do the adding, subtracting off to the side, I'll do it in a different color. I'll do blue-ish. So if I add these off to the side, so I want to figure out how many sig figs that is. So I do 16.0 plus 0.003 plus 21. That gets us our 37.003 for that. But now let's ask ourselves where each number sig figs end. The 16.0, it ends where? Hey, it ends in the 10th place. It ends right there. The 0.003 ends in 3 past the decimal. Then you have the 21, which ends in the ones place. So in this case, which number do the sig figs end first? The 16.0, the 0.003, or the 21? 21. That means I'll finish drawing my line straight down from the 21, meaning my denominator technically is only going to have how many sig figs? 2 sig figs. Based on that, hey, we got this 37.03 from just adding right here. Then the last step, so this is why this problem is actually relatively difficult. The last thing we did was we divided these two numbers. And when we're dividing these two numbers, hey, we had one number that had 3 sig figs and another number that had 2 sig figs. So my final number is going to have how many sig figs? 1, 2. So your actual answer is 0.95. We'll do some other ones, but I want to get to some density stuff first because that's going to be important as well. So definitely 0.95 for this one. But also, here's the thing. Don't round in between your steps. So like if you used your rounded numbers, so this is wrong. So don't do this. This would be 35.2 divided by 37. Let's see if it actually comes out to be the same. It might be different. 35.2 divided by 37. Oh, comes out to be the same. It's still 0.95, 2 sig figs. But just be careful that you don't round because every once in a while, if you round too early, your numbers will be off. Yeah, so don't round too early. All right, that took a lot of time. Sig figs. Sig figs is important though. One of the most important things because from here on out, everything has to deal with sig figs. Let's talk about density now. Density is mass over volume. And in a density problem, you really are only going to be given two numbers. You're either going to be given mass and volume, so you can find density. You might be given density and mass. Why did you write A? That's a D. Should I make it a capital D? This, I'll make this part taller. Yeah. Is that more D-like? So D equals M over V, all that stuff. So typically, at least for density problems, you can use that little pyramid trick. Pyramid density is mass over volume. I just don't like it because you guys should be good at algebra so that you should be able to solve for a variable even if it's on the bottom. But if it helps you out, you could use it, but definitely get better at that algebra portion. For this, so I guess I'll give you three problems. Each of the different ways. So calculate. There's one question. All right, try these out. Three separate density problems, and these are the only different ways that we could give you density. Oh, part of it's cut off. Is it the elephant one? I don't know. Aiden somehow got an answer, so I'm assuming other people could see it. Right side of the whiteboard must be a phone problem. Sounds like a phone problem. Here, I'll try to move it. Awesome. Indeed. First unit's always small. Ooh. Dylan, you're missing some important stuff. Same with you, Aiden. Or at least for the 5.04 one. Muy importante. Yeah, units. Don't forget units. SI without the accent mark is if. You need the SI with the accent marks. Too lazy to type it, but on a test, you're going to write it. Right, Dylan? Of course. All right. Let's talk about this first one. Calculate the density of Aaron if he has a mass of 177.83 grams and a volume of 35.3 milliliters. So density is mass over volume. And luckily, they gave us mass, which is grams, over a volume, which is milliliters. And 177.83 divided by 35.3, it gives you 5.037 dot dot dot. And I want 3 sig figs based on the 35.3. So 5.04 grams per milliliter. Good. Aaron approves this problem. Who says I was talking about this, Aaron? All right, so for the next one, let's get rid of this. Calculate the mass of a puppy whose density is that, volume is that. Must really make the test especially hard for Aiden / Preston. Oh, brother, Preston, fam. It makes sense. This is the year of the siblings. So many siblings. All right. Density is mass over volume. We know the density is 8.2. Whoa, what is that? 8.2 grams per liter. We don't know the mass, and we know that this is 17.3 liters. And you want mass by itself, so in order to get mass by itself, you're going to multiply both sides by 17.3 liters. And if you do that, if you do all your math with the units, the liters cancel out. The 17.3 liters cancel out here, leaving you with 17.3 times 8.2, which is 141.86 grams, but correct sig figs, which would be 2, so my answer is 140 grams. Nice. So for that last one, density is mass over volume. The elephant has a mass of that density of 10.0 grams per milliliter. Has a mass of 8382289 grams over volume. This is a point anytime you have a variable on the bottom, I always suggest you just cross multiply, make life a little bit easier. So if you cross multiply, you get something like this, where it becomes 10.0 grams times volume equals 8382289 grams milliliters. You're like, all right, what the heck is a gram milliliter? Then last thing you can do is divide both sides by 10 grams, 10.0 grams. So if you divide by 10.0 grams, the grams will cancel out, leaving you with, you just divide it by 10, so 83822.8, but you want 3 sig figs, so the answer is going to be 838,000 milliliters. It's good. So that's just some density problems. It's toasty in here. Can't you cross multiply for every density problem? Yeah, you can. And sometimes there's no point to cross multiplying. Like if you look at that first one, density is mass over volume, and you have mass, you have volume. All you have to do is divide those numbers. That's a little bit of density stuff. $57 to an hour and 9. How long will this GVL be? We're almost done. Unit conversion and water is going to be pretty quick. So unit conversions, like if I told you, that's a good one. I don't want to get a habit of just always using one. Well, super dark. I guess I like the teaspoon one. So for every 1 cup, there's 16 tablespoons. For every 1 tablespoon, there's 3 teaspoons. It still uses ones though. I'm gonna change it up. I'm gonna say for every 3 puppies, it's same as 7 pizzas. For every 2 pizzas, there's 19 cats. So if you have 381 cats, how many puppies do you have? So granted, this is like a nonsensical unit conversion. You should still be able to do this based on the conversion that I gave you up here. So try that. You could. I might get bored on. I'll probably make the test sometime tomorrow or Wednesday. So if I get bored, I might just make these nonsensical ones. You should still be able to convert though. Yeah. So Wednesday and Thursday we'll be reviewing for our test on Friday. Anyone have the answer for this weird problem? Oh, Dean's here. I should have added something about bananas. 82. Yeah, we'll have a couple of review worksheets and stuff. – 17.2 says Aiden with a question mark. No sé, ayúdame. Pues yo no quiero ayudarte. Ayudote. Ayudarte. No quieres ayudarte. No quiero. Yeah. Spanish. Only one person? 20 says Annabelle. Ooh. 18? 20? How do you know how to speak Spanish? I know everything. Well, my Spanish too is weak, but I was dead. 20 says Dean. Alright, let's see. So there's 300. 300? How do you say 300? 381 gatos. 381 gatos. Necesitamos podar los gatos. Alright, we have to get rid of the cats first. So if I want to get rid of the cats as a unit, am I going to put them on top or bottom if cats are already on top? Yeah. Bottom. Thanks, Annabelle. So we're going to throw cats on the bottom. And we only know our converge. We can't go straight from cats to puppies. We only know from cats to pizza. So, all right, let's go to pizza. So I know that for every 19 cats, there's 2 pizzas. If I stopped here, I would be able to convert from cats to pizza. So cats cancels out. And if I end here, I have pizzas. But I don't want pizzas. I want puppies. So in this case, pizza is back on top. I need to get rid of pizza. Pizza is going to go on the bottom. And puppies are going to go on top. And I know that for every 7 pizzas, there are 3 puppies. Pizzas are going to cancel out because it's 1 on the top, 1 on the bottom. And if I pull out all these numbers, it's 381 times 2 times 3 over 19 times 7. And if I just do this like a normal person, 381 times 2 times 3 divided by 19 divided by 7, we do get 17.1879 ... So then I look back and check my sig figs. All right. And for those of you that use like 1 or 2 sig figs, remember, granted this was some like weird units. Anytime I give you anything where it's like given in the sense that, okay, these are for sure known conversion values, that means you don't use these conversions. So typically for conversion values, we don't use these as sig figs. So the only sig figs we actually have is the 381, which is 3 sig figs. So it'll be 1, 2, 3. So my answer would be 17.2 puppies. I don't know how you would get a 0.2 of a puppy, but that. So unit conversions, typically I'll give you how much of this for how much of that. And you don't use those numbers as part of your significant figures. All right, and the last thing we'll talk about, what do you say? Oh, look at you using accent marks and everything. Is water. Someone asked about water. It might have been Kaylin, might have been someone else. But water is that special one. So on the quiz, I had you guys do like 9.51 milliliters of water is the same as how many centimeters cubed of water. And just remember with water, 1 centimeter cubed of water is the same as 1 cubic centimeter of water, which is also the same as 1 gram of water, which is also the same as 1 milliliter of water. Meaning if you have 951 milliliters of water, then you also have 9.51 centimeters. If you wanted to show your work, knowing this conversion, we could show our work. 9.51 milliliters. In this case, what do we want to get rid of if we want to go to centimeter cubed? We need to get rid of milliliters. So milliliters are going to go on the bottom, and centimeter cubed is going to go on top. And knowing this conversion for water, it's like, hey, for every 1 centimeter cubed of water, there's 1 milliliter of water. The milliliters cancel out, leaving you with, if you wanted to show all of your work, you could do 9.51 times 1 over 1, which is just the same, 9.51. So that's just something special about water, where water has that 1 centimeter cubed, same as 1 cc, 1 gram, 1 milliliter. Like show your work, the conversion for this one? For water, no. Just because we kind of talked about it. Yeah. But yeah, all right. With that, I think we're done. Dang, first GVL, an hour, 20-ish minutes. I wonder, and this is supposedly the easiest unit. Is there going to be a question including converting water on the test? Probably. Wait, that's all that's on the test. Well, Dean, you came a little late. For those of you that are in my class, don't worry. We'll review a couple days before the test so that you guys are all ready. And I'll give you a list of like topics that you'll need to study for. But yeah, thanks for coming. I'll see some of you guys tomorrow. Don't break stuff in our lab. And I'll end the recording. So typically what happens